Hello, everybody. This is Joram Barrez from Flowable, and today with me I've got Filip Hrisafov. Am I pronouncing it right, Filip?
Yeah, that's correct. Yeah, Filip Hrisafov. Yeah,
Oh,
it's not an
brilliant.
easy name for
No, it
non-English
isn't.
speakers.
It isn't. So today we're going to try something new, which we actually have not done in the past. So we're going to try something which maybe is a cross between a webinar slash a podcast slash something that will end up in also a blog. And it was actually inspired by my good friend Josh Long, who made a video, a Spring Tips video, a couple of weeks ago, and I've got the link here. If you want to see it, it's a great introduction to Flowable or to BPMN in general, actually. And if you go to flowable.org, go to the documentation section at the top here. There's a link there to the YouTube video where you can, for 1 hour listen to Josh talking about the history of Flowable, BPMN, and all that sort. And also just how to create a new project with Spring Boot and Flowable. It's very good. I would really advise you to watch it. But today we are going to talk about something. It's going to use Spring Boot for some part, but we're going to talk about Flowable in the serverless world. There's a lot of content to cover. We made a bit of a slide deck here. It's more of a, try to keep us on track, but we also have lots of code to demo. So we're going to switch in between slides and between IntelliJ, where we'll show you the code. The first question, or the first topic that we got to answer is, what is serverless? Because there's a lot of definitions out there. It evolved over the last maybe years, a couple of years, that it evolved into what it is today. But there's a lot of talk about it. The big cloud vendors, the likes of Amazon, Google, Microsoft, they are heavily investing in it. Of course, as usual in the software industry, they're heavily hyping it too. I think personally it's maybe not such a good name, as people get confused when you talk about serverless. In the end, there's always going to be a server to run your software. But the better name maybe would be that you get your server on demand, or basically you don't really care how the server that's running your logic is implemented or what's the infrastructure behind it. You are using a service for that, and it's not your problem anymore. Currently, basically, what the way serverless evolved, because it comes from a whole history of different paths it took. There was also if people remember that, the mobile backend as a service one point, and you could argue that that also was serverless, but the definition today, if you Google around, is really about functions as a service. You've got some sort of input, you've got your logic, and you've got your outputs, really function as a service. And the core ideas are around the operational side. Your server is not running all the time. Your server is only booted up whenever you need it, which makes it a prime example of handling peak kind of loads or slowing down when there's not many people using your application. And you only pay for what you really use. That's really the core of serverless. There are some simple examples, which, if you have a UI in front of you and you need to fetch some non-crucial part of your UI, you can do that in a function, right? That function does not need to be running all the time. Similar for a backend function, for example, you want to asynchronously process something, a document, for example. You want to do that, you want to offload that. It doesn't really matter how long it takes, or it doesn't need to be synchronous whenever the user is doing something with it. That's a prime example of using a serverless function. Another great example is training a machine learning algorithm. That data set generating that's also a prime example of serverless. Now, if we look around a bit, there's people that have written a lot about this, and what Martin Fowler has to say about this is that fundamentally, function as a service is about running backend code without managing your own server systems or your own long-lived server applications. It's not your problem anymore, it's somebody else's problem. You're paying a service basically to solve that for you. The deployment becomes an implementation detail. You got your logic, can be written in any number of languages, and basically you don't care what it runs on. It could be Docker, Kubernetes, something else. It doesn't matter. You don't care. It's up to the vendor, the cloud vendor, where you're deploying your function to. One thing is that, of course, as everything in software don't rush into it. Just making everything serverless doesn't make any sense. Really think about what makes sense to put into a function to make serverless and what not. Most of the typical kind of CRUD applications don't really have a purpose of making it serverless. So think with your, as you say, with your good brain on, so to say, that you don't go into crazily in this serverless world. An example of somebody, a cloud vendor offering serverless kind of things, they call it Lambda, AWS Lambda, is Amazon. Now, without going into too much details, it's basically your Lambda, as you see on the screen here, basically that's your logic. And your Lambda gets triggered by some sort of external trigger. In this kind of example, it could be an API gateway, it could be REST, for example, but it could also be a message on a message queue, it could also be something triggered from a database. The point is that doesn't really matter. You just define your logic, and you, as you have a screenshot about for that later, basically you configure how your Lambda will be called. And you can have any number of Lambdas, of course, in your environment that you expose to the outside world in various ways. Now, Amazon is not the only one. Google, as I said, also has offerings here. Microsoft and the Azure platform also has offerings here. There are plenty of others out there. Now, the benefits are, of course, easy to see. It's in the end, it's about costs. It's about not paying for server time when you're not needing it. It also is about simplifying operational management. You don't need to care anymore about running your software on a particular server, and you don't need to manage that server anymore. That's all done by the cloud vendor. But of course, as usual in software worlds, there are a few downsides. At the moment, it still is quite a bit of a vendor lock-in. There's no really kind of abstraction for that. I mean, there are some things going on to make that abstract, but it's all very early days. Security. I mean, if you only have a function running, how do you secure it? How do you make sure that your authentication authorization is properly implemented? How do functions discover each other? It's another problem you need to solve. And debugging. If your server is not running all the time, how do you debug something like that? What if if you have a function, it goes down and you were debugging, how do you solve that? There's all kind of problems that are different from when you have a persistent server running. And one of the things that when we started thinking about it is to look at, okay, from our side, from the Flowable engines, what are our challenges? And there's two kind of big ones. So Filip and me, we started going onto this adventure, and when we were researching this, we started by profiling basically the engines. And correct me if I'm wrong, Filip, but basically what we saw is that there's two big chunks, right? There's state. We store a lot of state because that's in the end what our engines do. And when we boot up the engines, there is a connection pool being created. There's a schema check in a database, and that is taking some time. It's not a lot because it boots up very fast, but relatively speaking, it's quite a lot compared to booting up something, right? And that's where we started working with what's the idea that when we started this serverless adventure, what's the idea that we want to implement. And the idea really is to have a function that starts a process. And to make things easier, we went with a straight-through process, meaning that it's going to start the process and it's going to continue until the very end. There's no wait state in between. And if you look at it, basically, you've got your input variables, could normally come from a form, from a mobile application, doesn't really matter, but you got your Lambda, you got your Flowable function, and basically, that's the one being called, and process gets started, process gets executed, and whatever the process outputs, that's what we return as a result of calling that function. So that was really the idea that we started with, which we wanted to do. However, there are a few problems along the way. Filip is the expert here on this topic. I'm gonna leave it up to him to talk about these, quite advanced words on the screen.
Exactly. So as Joram mentioned, so when we boot up, we do a lot of processing. So we check the databases to create the database tables. We also deploy the model. So when you use the Flowable modeler, you designed your model, and that outputs a BPM and XML, which we then import, we then process, and then we generate in-memory Java representation of this model, which is then used to get executed. So we said, instead of doing a database, we said, okay, we're going to use a node database. It's a straight-through process. We don't need that without wait states. And for the models, because we also saw that it also takes some time to load all these JAX-B classes and to process all this XML, we said, why not do this in advance? So why don't we do it that before we boot up the process? Why don't we just write this Java code directly from the XML?
Yeah, it seems like this XML, when we were profiling it, it seems like on the JVM, XML processing is quite heavyweight, at least the first time, right? The next invocations are fine, but the first time, for some reason, we saw a lot of class loading, we saw and a lot of, things that just needed to be there for XML parsing, and
Exactly.
that's quite interesting to see that. But of course, the subsequent invocations were fast because the JVM already had them loaded. But it's in the serverless world, that's a problem, right? We can't have these kind of slow things. Slow between quotes again, because we're really talking about milliseconds here, really. But you want to get as fast as possible, and that's yeah. Sorry to interrupt you, Filip.
Yeah, no, it's exactly like that. So instead of doing that parsing, we're just going to create Java code, which is just going to do this. We'll generate Java, which will just be bytecodes, basically, and that's much faster from what we saw. I mean, much faster in milliseconds, but still, it takes some time. So, as we said, so we reduced we removed the databases. We are not doing database calls. We're not doing schema validation because everything is in memory. And instead of starting a process, we are not doing XML parsing, and we are not deploying the XML, but we're deploying the Java model. And yeah, exactly. Like I said,
you're getting ahead of yourself.
Yeah, I'm getting ahead of myself. Exactly. Yeah. So instead of doing the XML, what we have in Flowable, we have these BPMN models, which is basically the representation one-to-one to the XML that is generated in Java, and then you can't get as faster than that. So it's Java basically, and then we can show. I think now we can go to the code.
Yeah. So just as a side note about the slides is that some of you might have seen some talk about this ahead of time compilation in some other presentations. There's a lot of talk about that right now. The name itself, isn't that great in the sense that it's not really about you're not compiling something ahead of time. You're basically generating something during compilation. At least that's how I understood it, right? Filip, you are also the project lead of Mapstruct, and that's exactly what Mapstruct is about, right?
Exactly. Yeah. So it's annotation processing, basically ahead of time compilation. Some people can say it like that. For me, it's more annotation processing, which is a technology which is there in Java since I think Java 1.5, and it's quite powerful. Basically, it generates the Java code which you need during compilation time. It can generate plain bytecode, or it can generate normal Java classes, which then get compiled to bytecode, basically. So it's like Joram said, it's generating code in advance that will be optimized. Then it's up to the JIT then to optimize it as well. So, or if you use,
everybody else is calling it ahead of time compilation. So let's just
let's go with that. Exactly.
with this side note. All right, do you want to switch the screen, Filip? Because we're trying this, we're as you can see probably on the video, we are sharing a screen through Slack, and Filip also has a pointer, and he can, drive my screen as he wants to. So we haven't tried this before, but let's see how it goes. So Filip, can you try to switch?
I do Command Tab.
Right, that's the other one.
Okay, that's the other one. Okay, so it needs some.
Here we go. Yeah. Oh, no.
Good that it didn't crash. Oops, wrong one.
Here we go. Yeah.
Okay, yeah, it takes a bit time. So first we're going to go through the high level to show how, basically to show the processes that we have and how we are going to do that. So as a basic, we have one process. This is the Star Wars process, right?
I've got a picture for that, Filip. Let me just switch to it.
Exactly, I think. Yeah.
This is the process.
Exactly.
Now it's not an advanced process. It's not a hello world process either. But it does something real. What it does, it gets in some variables. It goes to a REST API somewhere on the internet. I think it's a Star Wars REST API to ask information about Star Wars characters, and then it goes into exclusive gateway. And it checks whether the Star Wars character is a robot or not. And then we're gonna put put the data back to the user. And that's basically it. We just want to have some example that's not Hello World.
Exactly, and this is how it looks like basically. So this is how it will look like in XML. However, we can also write this by hand with Java, just with Java if you want to do that. But it's a bit more cumbersome, and it's not that user friendly. But it's much easier to go into the Flowable modeler and just do what was shown on the picture. So in order to do that, what we did is basically one just needs to define a class, just any class basically, and then use this at BPM annotation, which is a new annotation from our experimental module, as you can see.
Oh, maybe to mention all of this code that we're showing now is all prototype code. They're all on GitHub, but they're all very much work in progress. We're still experimenting a lot with them, prototyping them, trying out some new ideas. So, don't get fixed on this particular name or something. This is really experimental, hence why we also put it into this experimental package just to indicate.
Just to display that. But it's work. So we have something which is working and which is nice. So what we basically do is we have this test process. We just put the location which is on the class path, and if you just do normal, if you compile it, it's going to generate something that looks like this. So you see, this is in the generated sources basically. So the Java C compiler does this for us, and what it basically does, it generates exactly what the Flowable engine itself will do once it's processed. The model. So it creates a new model, and then it creates the example process, basically setting the ID, the name, and all the information which we have basically from the XML. You see here we have the API call, which we are doing to check for the Star Wars API. And
there's a lot of code. You don't want to write this by hand, right? This is normally what the XML parser also would, behind the scenes at least, you never saw this, would create. But you could also, with Flowable, there's an API to write this. But as you can see, it's quite low level in the end, because you are generating a full-blown BPMN process, and you don't really want to write this by hand, I would say.
Exactly. And in order for us to write this, what we are actually doing is we have the annotation processor.
Oh, it's here. I think I opened it here already. Yep.
Yes, that's the annotation processor, exactly. So what it basically does, we actually use, so I think this one.
Mm-hmm.
Basically, we get the element, and then we are not doing anything during compilation time. We use what actually Flowable will use. So we are using the BPMN model. We get the process, we process it, so there is nothing special that we are doing. So we are just generating the model like we would do in the normal engine. And then, based from this model, we are creating the BPMN model. Basically, we have this bunch of code here, which uses Java Poet, which is a really good library for generating Java code. And basically, it adds all the functions and all the elements which need to be added for it to be then restructured, so created again from Java. And then we have here one demo application, so we can show how it all works.
That's for later. I need to first talk about a few slides then.
Okay, then let's go back.
You're getting rid of yourself again.
Yeah, sorry.
No worries. Let me sweep to the thing again.
Yeah.
We forgot about that, right? So there's two, and I know where you're getting at. That was my problem, my fault. That I know what you were trying to show. Yeah. So indeed, there is two kind of. This is the one part of the problem, right? If we go back to our problems, right? It's one part was the XML. The second part that we're talking about here, this is then solved by this annotation processor. But there's also the connection, right? So and that's
exactly that's the second problem.
It's not really that sexy, but let's show it anyway. But because in the end. What this is all about, and indeed, sorry, Filip, for interrupting you. Basically,
it's fine,
we created a node database process engine configuration, and due to the fact we've got a very nice abstraction of persistency in Flowable, that was almost, let's say, trivial. Right? There's a few settings we do here, we have to say, but basically, what we do is we create it's not a great name if I read it like this, like NoDB, DB SQL Session Factory. That's because the internal name has been always DB SQL Session Factory. But the point is, it doesn't do anything, right? Every of the methods that are important when it comes to persistency, they're just either return null or they are empty. So there's no commit, there's no rollback, there's no flush. And basically what we do is we run the engine as we always were running it, but we simply don't commit it to the database, or we just don't, if there's an error, we don't roll it back. And it doesn't need to, because we don't store anything. And what's cool about that is that the engine internally has been designed to, as long as you don't flush, this method here, as long as you don't flush to the system, to the database, then you keep everything in the local cache. We have a transaction level cache, and basically as long as you didn't commit it, it's in there. So that means that you can have any number of steps in your process, and you can reference any previous step in your process in the next step, and still that works because the whole persistency layer has been written in such a way that it knows about this cache. And this is why the implementation, as I said, is not that spectacular, but it's pretty cool to see that it was that easy to enable no database basically in Flowable. And there's one little thing which we also need to talk about, Filip, is this kind of the way that this thing works. Now we call it deploy serverless process definition. And Filip also already talked about that, is that normally the normal way would be to take a BPMN XML, parse it, and store something in database. And then whenever your engine boots up and you're referencing this particular model, this definition, process definition, you would basically fetch it from database and reparse it again and do that Java model, and there you go. Now we can't have that because we don't have a database. So for this, we do a little kind of workaround, which is we inject it directly into the cache. There is a low-level cache for process definitions, and basically what we're saying here is that after we've parsed it, we generated that model with our annotation processing, we inject it into the cache so that if you, as a user, say, I want to start this process definition, the cache is immediately hit and there's no database being involved anymore. We can make this, of course, cleaner. Again, this is all current experimental prototype code. We can make this a lot cleaner and build this into natively into the engine. But just to give you an idea, of what this is.
Exactly. Yeah.
All right. Let's switch back to the thing. So yeah, one of the first things then, what we did was like, let's try a simple function, right? As I mentioned, all of the code is on GitHub, and the link is quite easy. Just go to the Flowable repository on GitHub, and you go to the Flowable serverless project, basically, and all the code is in there. So let's have a look at that. And again, there is nothing special about this, because in the end, Flowable was designed with this pluggable persistency in mind. This is a static initializer thing. We need to clean this up, right? You see a few of to-dos here. There's a few comments. This is because this is really a work in progress. But we wanted to talk about this because it's pretty cool stuff, as you'll see in a few slides. There's some really great results for this. But we're going to clean this up. We're going to make this nicely, as usual, nicely cleans up in a nice API and stuff like that. So what we do here is we've got a plain old kind of a Java class with a main, and what we're going to do is we're going to start up 100,000 of processes that we've injected into the cache after being generated with the annotation processing, right? So this is actually, see, we're using a simple service task. It doesn't really matter what example we use here, but basically we're getting a BPMN model back out of it, and that's the BPMN model we're going to inject within that cache. And then we're going to just start as you normally would do. This piece of code here, this main. You can't see that this is running without a database, and this is actually a function, right? So this, what we're going to try is we're going to start this. It's going to start 100,000 processes. Now, the times you see here are because I'm sharing my screen now, and I'm doing screen sharing with Filip. I'm recording the movie. It's not the real numbers, so I've got some real numbers in the slides. We've got them later on. But basically, we started these in whatever you see the numbers here, less than 1 millisecond per instance, and this is to this was the first kind of thing that we built just to validate the whole annotation processing / injecting into the cache, trying it out, just that our ideas were fit. Yeah, that was basically where we started, and then things become really interesting, right, Filip?
Yeah, we said then, okay, so it works. It works. It is fast, so we can make it work without persistent, and we said, why not try something else? Why not go next step further, and then we maybe use Spring Cloud function and have a REST layer on top of it, so we can then just execute it. So what is Spring Cloud function? So Spring Cloud is a tools framework from Pivotal, which is built on top of Spring Boot, and it allows you to build distributed systems. It has internal discovery between services, circuit breakers, load balancing, etc., etc. So, and from what we've used from here is we've used the latest Spring Cloud, so 2.0, and basically we create a function which is reachable over HTTP, and then it's packaged as a normal executable Spring Boot jar. And as Joram mentioned before, everything is open source, so everything is in our Flowable REST repository, and it's actually really simple to build something like this.
Yeah, let me switch then to the IDE.
Yeah, switch that so I don't make a, yeah.
I'm gonna close all the other ones, and there is,
exactly.
Let me take the right one. It's this one, right?
Yeah, it's this one, exactly. So what one needs to do is basically, as for a demo, because it demos nicely, you can make your main application a function which accepts certain string, and then it outputs a string. And basically, the static initializer is what Joram showed before. That's exactly the same. There is no difference in there. And the main, you can see here, is a bit different. So the main is it uses functional Spring application, which is coming from Spring Cloud, and this will make your application as a function. So this will make it accessible over REST. And what it does, basically, it has a value, and then starts a process instance, and basically it starts the process instance,
so
and then returns that.
Exactly. Literally, the function is starting the process, right? Maybe before we run this, the kind of dependencies you need for that is basically, it's quite simple to say. Basically, you got to add the Spring Cloud starter, the right starter to your project. And in this case, we're using the Webflux. There is alternative for this too, but the Webflux will enable the HTTP stuff that Filip is talking about, and that's pretty much it. Now we did a few tweaks, like adding the content indexer and trying to speed up the boot time, because we got some performance numbers afterwards, but that's basically it. So let's try to run this, right, Filip?
Exactly, I try to run it.
Here we go. So here we go. And this is literally what it does. This is literally, just to put things in perspective, this is a full-blown REST server. I mean, there's a whole HTTP REST endpoint listening to on the server, and when you hit it, when you call this REST service, it's going to start a process, and it's going to return whatever in that process. You can see that, right? It's going to return some information about the process instance ID. Let me switch to the terminal, because I prepared this here. So basically, I'm gonna, again, this is all demo kind of demoware. So we're gonna just put some data in there. It's just tests. It doesn't really mean anything.
Yeah.
The point is that we're invoking this. We're getting back a process instance identifier, and in this particular example, we're also printing out the number of times that a Java delegate was being hit. So if I hit this like multiple times, you just see that this is going up. So this is quite cool, I would say. It's literally a full-blown REST server with a process engine, and it starts a real process, not a hello world process. So this, I mean, I really liked when we were building this. I really liked the Spring Cloud, kind of how easy it was. As you know, or many of you know probably watching this movie, is many of our tools, of our UIs are written in Spring Boot, and building this kind of integration was almost, I'm not going to say trivial, but it's very close to it. It was following the patterns that we're used to from Spring Boot. So that was really nice. I was really impressed also by documentation and how it all just works. It's really cool.
It's just like, it's not difficult to set it up, and it's really easy. If people have used this Spring Boot, then it's really easy to use this as well, Spring Cloud function.
But of course, the question that everybody then asks is, how fast does this boot? Because in the end, that's what we're doing it for, right? We're doing all this hassle basically to make sure that the cold boot up time of our function and of our process, starting a process as a function, is really fast. And we've done some benchmarks. Again, with all the benchmark, take them with a pinch of salt. There's a snapshot of time and certain setup and whatever. But it gives you an indication, not that the numbers itself, the absolute numbers, are important, but the ballpark number is important here, right? So all the benchmarks were done on an iMac, quite an old iMac. Still, it's one of my development machines. It's a 2015 model, i7 CPU, 16 gigabytes of RAM. So traditional kind of machine you would expect things to run on. If you use the quite an old Oracle JDK, you basically can see there's a little red line under here that the thing we just booted up from our IDE, if we build a jar and we then run it from the terminal, basically the JVM with a Flowable engine completely booted up, the boot up time was 1.178 seconds. So very close to a second. Would have been nice to be just below 1 second, just for the sake, but here we go. That no need to sugarcoat it. 1 second. If you ask me, it's really great to have a real server, real HTTP REST server with a process being started that really works. But of course, we didn't stop there. Just before Christmas, there was this blog from David Sire, which I really advise people that use Spring and Spring Boot to read, is that just talks about how fast is Spring and ways to basically make Spring boot up faster, or how to just do things faster. Adding no verify to executing a jar makes a big difference. It skips a lot of stuff that you normally need, and if you can do it, if you're allowed to do it, it's always makes things fast to boot up. There's a few kind of things in the blog that were mentioned, like tiered stop at level 1. Basically, it means that the JIT is not going to try to do some optimizations that it otherwise should do. It actually gave us worse results. Pre-touching classes, jars, should have made a positive difference, but for us it didn't. Exploding the jar, so instead of at runtime, that when you use a Java -jar, instead of the thing being unzipped or unjarred, which is also an unzip behind the scenes, in memory, just do that up front and run the exploded jar. Didn't seem to make a difference, at least, again, on this setup, on this benchmark, on this machine. It could be very well be that if you do this benchmark, you see differences here. But the other interesting thing in that blog was JDKs. And of course, with the whole move of OpenJDK and Oracle licensing being changed and all that, that's quite an interesting area to play around with right now. So the first one we tried was the Adopt OpenJDK 11. And basically, we expected better results because, should be faster, the JDK 11. But actually, for this use case, it wasn't. As we see in the boot up time here for the whole thing, it was 1.3 seconds, which is relatively quite a lot compared to 1.8. However, this was the default Adopt OpenJDK kind of distribution. In the blog post from Dave Sire, there was also mention about the Open9 JDK. And this is basically a different distribution. I believe it has some things that IBM has donated to open source. When we tried this, by default, it was actually worse. You see the number here, 1.8 seconds. That's really, really, completely different, relatively different ballpark number we're having here. However, in that same blog, there was mention of a whole bunch of settings you could try, share classes, quick start, whatever. Basically, if I understood it right, what this does is that basically once you boot it up for the first time, it would create a file in your system that would help it boot up faster, probably by doing some class path kind of storing some results of some class path scanning and class loading, whatever. Point is that when we run this, actually we were now much closer to this 1 second. So again, if we go back to our first result, here we go, 1.178 seconds. We got it down to 1.021 seconds, which is relatively quite a big difference again, 10%-ish kind of improvement on things. So just by switching the JDK and then having some settings, of course, different settings. Now these settings are only available on the Open9 distribution. They're not available on the other distributions. So yeah, it's quite interesting. Of course, memory. That's always also something because as we will see later on, in the serverless world, you pay by execution time and by memory. So the more low you can go, the better. And the lowest amount of memory that we could go with this example, basically, was 7 megabytes. Now, if you would execute the request to curl that we did just earlier, it would be very slow. I mean, it would be like, I don't know, 2 seconds, 3 seconds before it actually responded, probably because garbage collection was going like crazy. Again, 7 megabytes for a full-blown HTTP REST server with Flowable, with starting a process. It's just crazy. It's a great number. And, don't run this on 7 megabytes if you really want to have a fast response. But just to show you, that the footprint of Flowable and Spring Spring Boot in this case, is actually very, very, very low and very well suited for this use case. And of course, we built this thing now, we ran it locally, and you want to run this, you want to try this out. And the platform we choose to run this is the AWS from Amazon, AWS Lambda platform, using Spring Cloud. Now, we decided to go with AWS and Spring Cloud because it has some really nice integration. Again, the way it works is actually just the same. So let me just switch to the thing, and let me switch to it's also called demo application. Yeah. It doesn't look different. Well, there's a bit of difference here, right? I mean, Filip, you said before with this implements function, that also works. So you could package it in the same way. However, there's a blog. I didn't put a link into these presentations. There's a blog last week, I believe, that talks about this, and it turns out that using this kind of application context initializer way is actually faster when it comes to booting up versus the function kind of approach we were having. But in the end,
You're using the functional bin registration
exactly.
from Spring Boot 5.1. Yeah,
exactly. And it is faster in boot, but it's quite a substantial. Again, not a huge number, but relatively speaking, it's much faster compared to this. And basically, what we do here is we just have here a function bean now that's being called, and that's it. And then we register it manually here ourselves in the function registration. We just pointed to that bean that we have. Well, it's not really a bean. It's not annotated with a bean as such. But in the end, it turns, you're just doing a manual thing. And yeah, as usual with these things, the less kind of auto discovery you need to use, the faster things get, right? Now, we're talking about really millisecond differences here. One other thing that let me first switch to the Maven dependencies because they're quite easy. What we had to add beyond the normal Spring Cloud stuff was the Spring Cloud Function Adapter AWS kind of thing. Now, an interesting note to mention here is that this project and Spring Cloud, there's also contribution there, but this project is currently really being maintained, or one of the maintainers of this project is actually our CEO Agim, who whenever he finds time actually does it, which is quite cool to talk about. It's pretty cool to see. And because we're running on AWS, we also had to include these Lambda Java events and Java core. Now, the magic to hook this together, because the way that you have to package your jar for running on AWS Lambda is not the same as you would do a regular jar. It expects, for some reason, a very different kind of layout. And this is done by the, also very well documented, but also done by basically the Spring Boot plugin, but also very well documented on the repository or the documentation, sorry, of the adapter for AWS. The only thing you have to do, it's a bit weird maybe, but again, this is also very well documented, is you need to have like this Spring Boot request handler from the AWS adapter module, and you need this. Now, I don't think you actually still need this. Is something that we had to add in the beginning, I believe. I don't think it actually needed it. It auto-discovers this main class now, but in the beginning we had some issues getting this running. I think it was due to the jar layout being wrong. Basically, the jar layout that's expected is that everything's flat, so all the dependencies are also basically unzipped under the root of the jar, which is not exactly the same as a normal jar. That's basically what you had to do. Now, that's a lot of words, and let me just show you how that looks like for real. Now, people that don't have yet seen this, how this looks like in AWS, and I'm sure it looks like the same. So it looks similar in Google Cloud or Azure or whatever. When you click on the Lambda kind of section in AWS, you get to this page. As we spoke about, we were talking about how much memory you want to use and how much time your function, your Lambda, as they call it in AWS, is going to run. And as you can see here, you're paying a very small price per 100 milliseconds. Now, just some screenshots, you click on that button to basically create a new function. There's a couple of runtimes you can select from. Java is one of them. I think JavaScript, Ruby are other ones. And basically, you say, this is my Java thing. You can upload a jar to it and configure it. And the cool thing is that you can say what are the triggers. If you want to have in front of your Lambda, if you want to have like an API REST gateway, you just drag it on the screen and there you go. If you want to have like a DynamoDB kind of event, there you go. You just click it and it all, these kind of Lambdas, these functions, they all nicely tie things together. It's quite interesting to see how this is built up. And when you build it, you also have to say, I want to use that much memory. Again, we only needed 7, but the minimum we can choose was 128. And this is how long you want to run it, right? This is like, if you boot it up, this server, like how long you want to run it. And I believe you can choose up to 15 minutes for AWS. Now, there are projects out there, it's actually quite funny, that are out there that are made to keep a Lambda warm. So they actually ping the Lambda every so many minutes to make sure that they don't go down. Kind of defeats the purpose, but just saying that's the way currently people are using this. You can test it, right? In that UI, you can have like a JSON. You just, again, we just test data A and B here, value 1 and 2. Just hit save, and then you can test it out. And then you can get something like this. Again, this is the output we also saw on our terminal just before this. Now, the interesting thing is that, remember, we were seeing around 1 second to boot up a full server with Flowable answering over HTTP. If you see what we get, it's almost 17 seconds on AWS. And that's actually, there's two sides of looking at this, right? Either you can say, well, technically, there's a server going to be booted up. Probably it's going to be some Linux distribution. I don't know how this jar is going to be run. Maybe it's in Docker, maybe Kubernetes, maybe something else. Maybe there's some scripts there. I don't know. That's the point, right? With serverless, you don't know. And that takes time, as we all know that takes time. You see it takes 17 seconds. And there's a lot of articles out there currently, quite a lot of people writing about this, that with serverless, we are talking about cold boots, but we're not yet 100% there yet when it comes to really very fast cold boots, because our application took 1 second, but it takes like 17 seconds to boot the whole thing up, which, relatively spoken, is a lot. Now, the good thing is that once you booted things up within that time frame you said it needs to be kept alive, you're really, this function to start a process responded with a response in 1 millisecond. So once it's warm, it's really, really fast, and it's consuming not much. I mean, here it's saying it's using 108 just because, I didn't try to make it as small as possible, but, remember that we can run with a lot less memory. Interestingly enough, we only took 1 millisecond, yet we were built for 100 milliseconds. So, it's we should do way more in that 100 milliseconds with the time we were given. But that's another kind of a problem to solve.
Maybe that's why also people are keeping them warm, because it took 17 seconds to boot it up, but then afterwards it's not built for the time that it's up, but it's built for the time that you use it, it seems so.
Exactly. And I know, to be honest, I didn't look into the pricing. Like, if I run a Lambda for an hour versus if I run a server for an hour, what's going to be the most cost efficient? I actually don't know. I'm assuming that maybe the Lambda is more expensive. That would make sense, or maybe not. Maybe because it's currently hype technology, so to say, or it's in new technology. It's cheap. I don't know. That's an interesting thing to look at. But exactly. That's the the raw numbers as they are.
As a person can see them exactly in the UI.
Exactly. Now, another thing we tried, so we went, with this whole Spring Cloud. We're very much impressed by how easy it was to kind of take our Flowable as a function idea, implement it with Spring Cloud, and then, deploy it on AWS. But as many as you probably know, there's also, at the moment, some talk about Micronaut. Micronaut basically is a full-stack framework for really built with serverless in mind from the get-go. Right? And it focuses heavily on these problems for serverless, boot up time and memory. And there's an extensive use of ahead-of-time compilation and annotation processing out there. Again, the example is in GitHub, fully, if you want to watch it, fully open source. And let me just show you how that looks. I'm just going to close these. And I believe this, here we go. There's not much difference, with regards to whether you start, the way you run it, right, compared to Spring Boot. You also have a main, you also have some class you have to run. And basically what we have is this one here. We've got a process controller. We've got annotated with that controller. Again, the same static initializer we have everywhere else. And we've got some annotations here on top of methods. These annotations now come from Micronaut compared to the ones from Spring Clouds. But in the end, it's the same. When it comes to using Flowable, there's no difference. We're getting runtime service, we're starting a process, and we're passing some variables in there, and we're outputting that in the end. So let's just run this now. Here we go. And what Micronaut does is a lot of annotation processing to kind of generate or prepare code for you to remove all the things that you don't need. As you can see, you can't see that yet, but if I now try this, here we go. This is Micronaut, the Micronaut plus Flowable application responding with a new kind of thing. We put in number 6, it's just a random identifier. It says this is Owen Lars, and he's not a robot. This is our Star Wars process, right, that we were talking about. If I think number 2 is a robot. Here we go. Yeah. So number 2 is actually C3PO, and he's a robot. So just to show you that this is not, demo where it's actually really going out to the internet, doing a REST call, processing it, and all that. Now, the question.
And this is the process which we showed at the beginning, right?
Exactly,
the picture. This is that process, right?
Exactly. There's a process that I think I have still open here. Oops,
yeah, in your preview.
Yeah, here we go. This process here, so which calls out to a real REST service. How fast is it? Because that's, of course, a question that people want to know. Well, using that same Open9 JDK with all the settings that were found to be the fastest for our use case, this booted up within 355 milliseconds. That's, quite a impressive number. Now, it makes a lot of sense, of course, if you see, if you go and look in the code, what Micronaut does, the way they do it versus Spring Boot, it makes a lot of sense. There's also use cases that you can't really do with Micronauts, more around the dynamicity that you can do with Spring Boot. But in the end, the difference is quite interesting to see, that we could boot up a full REST server within Flowable within 355 milliseconds, and that's quite impressive. The memory usage is also the same, 7 megabytes, like we were seeing with Spring Boot. I think we didn't go that much into it, just try to build this kind of Micronaut thing, and the reason for that was actually because Micronaut has something that a lot of people are currently talking about, which is a nice integration with the GraalVM. Now, GraalVM, for the people, I didn't know it before. Well, I read about it, but actually, I didn't know what it actually was before we played around with it. It comes down, it's a JVM from Oracle. There's a community edition, there's an enterprise edition, but the quite interesting part for our use case, at least, is that it comes with what it's called a native image compiler. What it does is quite complex things. It basically looks at your Java and it's going to remove all the stuff that you don't need, and it's going to build let's call it an image. It's going to build an image that contains the stuff that your application only needs. So there's nothing else in there. It's due to compilation and due to following, the trees of the syntax trees and all that, and the abstract trees of the programming behind the programming language. It's quite complex stuff, and it's going to generate a image that contains the bare minimum, right? And the cool thing is that Micronaut contains, well, not Micronaut, but the Micronaut CLI contains basically default scripts that you can enhance for your own use case that build this native image. It takes a long time to compile. So the simple example that we just showed, one application with one REST controller starting up one process in Flowable, it takes almost 2 minutes on the machine from the benchmark to build this image, right? So it takes a long time, relatively speaking.
And we can say actually GraalVM does ahead of time compilation because it optimizes your current Java code. And that's why it takes 2 minutes, because it inspects all the classes which you're using and the paths and tries to remove the paths which you're not using and remove classes which you're not using, basically. So that's why it probably takes 2 minutes or even.
Yeah, absolutely. That's a good point. So this is basically the script generated by Micronaut. Now we added a few things to this script, but basically this is the binary that basically gets called to generate the artifact, right? Now let me just show you how that looks like. Here we go. So basically what we have here. So this is the Flowable Micronaut application. So basically, this is 55 megabytes, and this is the whole thing, right? Everything you need to run our simple process as a function. So if I start this, here you go, start it up, 26 milliseconds. Now, if you're impressed by this, you'll be impressed even more by the real numbers on my benchmarking machine, because again, I'm screen sharing, I'm recording a movie. We started a Flowable server that starts a process, a full-blown real process, with answering over HTTP to start it in 26 milliseconds. I think that's, just deserves a bit of pause here to
That's a good number, I would say.
It's quite interesting. And also to show you it actually works, right? Because you could not believe me. I'm just going to send another number here, now 7 into the Micronaut application. Go. It's a, whoops, let me just, it's a real server really starting a process. And that's,
And it doesn't require a Java, right? Because the exactly. 55 megabytes, it's
everything,
the native image, right?
Exactly. That's a fully native image. It's of course, because I built it on OS X. It's only currently running on OS X, but you can imagine that there's a Linux. There's no Windows built yet at the moment, but I think Linux and OS X you can currently do. And yeah, it's a fully binary thing that you just boot up as any other process in your Linux environment, and that's it. It contains the bare minimum to run it. Now, we make it sound like this was easy, but trust us, it wasn't. it took us.
It's not like it seems. Yeah.
The documentation there is documentation, but the documentation only talks about happy paths and all that, and there's to be honest, there's a lot of information in the GitHub issues. The team seems to be quite responsive. It's cool to see that. But once in a while, you run into some strange examples, some strange exceptions. For example, this one here. This was like saying, cannot find method get variable on a Flowable class, the execution entity implementation class. Now, I can assure you this method does exist because it just is the one that you use to get a variable from a process instance, for example, and you're just giving the variable name as a string, and that's one parameter. So why did it, why it said when I'm running it on Graal, if I run this not on Graal, just on a regular JDK, it works. In Graal, it doesn't. Now, the reason for that is actually because if I show you the test process, here we go. Here, right, this is a service task. This is a service task, as you can see. And the service task just has an expression, so there's no clause or whatever hooked into this. It's an expression where we're getting a variable and putting something in. And then this variable result is actually a hash map. Now, this is a string. And Graal, when building this native image, doesn't look into strings, of course. It only looks at Java classes, and it doesn't know what it needs. It just says, well, this method get variable is not referenced anywhere, so I'm just going to remove it because that makes the size smaller of this things. Now, the solution for that, took us some way to figure out. The solution to that is that there's you can pass when building the image, you can pass a custom reflection kind of settings configuration. And what we needed to do to make this work is expose or say to GraalVM, to the native image binaries, basically say, this class, just, take it in as it is, everything should be in there. Don't do any pruning whatsoever. And same for hashmap, by the way, because that was the next exception that logically followed after that. So it's really, and that also is a different way of thinking, because in Flowable, we do a lot of dynamic stuff, reflection-based stuff, like loading a class from a class pod, or discovering a Spring Bean, for example, if you want to delegate to a Java delegate at that point. That's stuff you cannot do when you build this native image without doing an extra step. So normally you would say, okay, I'm using this class, and then the Flowable engine would, for you, with reflection, create that class on the fly, make a new instance and stuff like that. Now you can't do that on Graal unless you manually would add your custom class to this. And then it becomes a bit tedious. But of course, there are use cases for it. But just pointing out that, as usual in software, with everything you gain, you also lose something. There's no silver bullets. In the end, it's all code that needs to be executed, and you exchange something. In this case, compilation time ahead of time, with stuff that you otherwise would get out of box. So it's quite interesting. Now, some libs are just incompatible. At least we found them to be. Really don't know why we couldn't get this working. It wasn't really necessary because we don't use persistency, but the point was that we had to explicitly remove this from our Maven POM to make it work. And that, this is not the only one. We had to remove a couple of those, and that was really trial and error. Trial, waiting 2 minutes, and error, to see it. So that was interesting. But
you gain somewhere, you lose somewhere.
Exactly, as usual in life, right? But on my fast machine, you saw 26 milliseconds just before. Well, the result I got on my benchmark machine was 14 milliseconds. So 14 milliseconds boots up the full server, HTTP ready, HTTP REST ready to start a real process. I think that's quite something. Even if though it costs us quite a bit of sweat and tears to get it all working with Graal and the native image compiler, the results is undisputably impressive, if you ask me, and it works. There's no difference with our previous example. It just works. It's quite impressive. There was one thing I didn't mention. Right, good that it's on the slide. Is that things just simply don't work. For example, we were using the HTTP task to call out to the Star Wars API. By default, behind the scenes, when you do that in Flowable, it uses the Apache HTTP client, which pretty much, everybody around the world uses for various use cases. Now, that simply does not work on Graal. And the reason for that is that it says, well, I see that a Java util timer is being used at some point in the code. I can't do that at the moment, right? At the moment, GraalVM says, nope, it just stops with an exception. And it just says, no, timer is not supported. And there you are, right? Our example that we built and suddenly it doesn't work anymore. So in the end, what we did is we kind of override of the behavior of the behavior of the service task, which in Flowable is quite easy to do because we have applicability point. But in the end, what we did is we extended from the default Flowable kind of thing, and we just did the old way, right? Where you very low level kind of created a URL and then you URL connection and then you manually set things on a connection, things that HTTP client normally would do for you, and get the result back, get a JSON node back stored in a variable of Flowable. Yeah, this is not, of course, stuff you want to, until you find this, it takes a lot of time. Also, there's a bit of documentation here. There is, when you run this at runtime, we would get like a unsatisfied link error. And the reason for that is because that image, for some reason, does not include some of this particular lib sunec diy. It needed that to run, and it needed that because this REST API was HTTPS. It worked for regular HTTP, but the moment you're starting to do, it needs HTTPS. Now, according to the docs, this should be enough, enable URL protocols HTTPS, but it wasn't for us. And then we found some other blog from somebody who basically found a solution to it. And what we had to do, let me just show you here. What we had to do is we had to copy this particular library next to the binary. And there's according to the blog, there's a way to link it to basically set a system variable and then link it that way. Couldn't get that working, sadly. And in the end, we went with just next to it. But just, for full disclosure, that's what we had to do to make it working. Yeah. The conclusion is, as you could guess, right, it's very interesting. It's super cool to see the whole thing boot up in just 14 milliseconds. It's amazing. But it's very early days, right? I mean, I think we're just at the beginning of these kind of things, and really something we look forward to invest way more time in and to see where we can take it with this, because I think the future is quite bright on this. It's really a really cool vibe around these things. Everything that we show today is on this GitHub repository. So if you go to the Flowable GitHub repository, it's in the Flowable Serverless project. Just go to there. Everything we showed today, talked about today, is there. You can just play around with it, try to build it yourself. Maybe even contribute something would be really cool. Just or just discuss with us on the Flowable forum. So what did we do today, Filip? Quite a bit, I think.
We did quite a lot of things, exactly. Yeah. So we showed that, we already showed this, that the Flowable architecture is really easy to work with. And so now we showed that before with the MongoDB support, we showed how easily you can do that with change the entire persistence layer. And now here we are showing again that you can easily adjust around the serverless requirements. Basically, we had problems with HTTP activity behavior, you can change that. No DB, we did that without problems. And we showed that, it works easily with Flowable and Spring Cloud, Flowable with Spring Cloud and AWS. And it also works with latest technologies like GraalVM, so Flowable, Micronaut, and GraalVM, which is, I think, something really interesting to see, that we can easily adjust to the new technologies.
I think that's the main conclusion, right? I mean, for us from the Flowable project, the architecture is extremely flexible, extremely pluggable, and has no problems whatsoever to cope with these changing world, right? If people want to do
it's a completely new world. Yeah, exactly. Yeah,
exactly. Anyway, I think we spoiled. Unless you wanted to add something to that, Filip.
No, I think that's
all right.
No,
because this is the last slide that we had prepared. So
exactly.
I hope you liked what we demoed. If you want to reach us, you can just ping us on Twitter, ping us on the Flowable forum, or on GitHub, whatever. Looking forward to hear about this and see how this evolves and where we can take Flowable with this. Thank you very much for listening.
Thank you.
All right. Bye.
Bye.